First of all, if you're watching this video and you have no idea what I'm talking about, it may be a good idea to watch previous episodes first. You'll find them in the description. Sure, it's a while ago since I've posted the video, but that's not only because I have a day job, I've also got a life. But let's get to it. Last time I promised you we enter M4 territory, and that means that we should be able to perform jumps and loops. So let's see how most interpreters do that. If you're a regular, you've seen this little program before. So let's put 2 on the data stack and run it. We see that this 2 is duplicated and then evaluated by 0 less, leaving a false flag. That means that we have to leave the loop by jumping to a repeat. Now, how do we do that? Simple. We continue to parse the program, however, without actually executing anything. And when we reach our target, repeat, we can continue normal operation. An excellent example of this method can be found in the minimal basic interpreters. Let's assume that x equals 4 here. So if we evaluate this if statement, we will find that the condition is not met. And these kind of interpreters will respond to that by simply jumping to the end of the line. That's it. No code is executed and normal operations is resumed at the beginning of the next line. For structured basic interpreters, the whole thing is a bit more complicated, since here we might have to deal with so-called nested if statements. If we just went for the next end if statement we encountered, we'd be resuming execution much earlier than intended. And that would introduce all kinds of ugly bugs. So how do we resolve that one? Remember, x still equals 4. The moment we encounter an if statement, we start a counter and increment it. We will keep incrementing it with every if we meet on the way. The next line also contains an if statement, so we increment the counter once more. The next one is an assignment, so nothing happens. But then we find an end if. The rule is we decrement the counter with each end if. So now it's just 1. The next line also contains an end if, which brings the counter to 0. That's our cue. Now we can resume execution. You may find this a primitive way to resolve branches, but it is actually how 40h bracket if and bracket then conditional compilation directives work. Now we can use those algorithms to turn our preprocessor into something that starts to resemble a full-fledged interpreter. All we need is a word that conditionally skips the remainder of the macro. And this is it. Question abort. The core of this routine just parses words and checks their length. A null string terminates this loop. And note there is a second item on the stack which is preserved during operation. That's intentionally because it's a flag and we will need it later on. We've seen in previous episodes that the end of the macro is indicated by a null string. So this word conditionally terminates a macro. That's it. Our add-if word gets a number from the string stack. If it's 0, question abort is called and we effectively quit the macro while preserving the flag. Add else is the complete opposite of add if. It quits the macro when the top of the stack is non-zero and inverts the flag. Now you say, what use could that have? Well, let's see. We've seen f% before, but this implementation is on steroids. You see, if we have to convert an integer to a float, we can use s to f, which is much faster than s to float. And this version is able to select the most efficient method. So we got a string stack and an output file, so let's get started. Let's process the expression f%25. We parse the next token and put it on the string stack. Then we call _f%. First we have to duplicate the top of the stack. Add cell will leave a true flag on the string stack if the top of the string stack is an integer. Then we call _s to f. There we have our first encounter with add if. Since the top of the string stack is true, we continue to execute the macro instead of leaving it. Note, the flag remains intact. Then we perform add over, which will leave 25 on top of the string stack. We destructively print that number, and subsequently we print the string S to F. Now we enter add else. Since we will only execute the remainder of the macro if the top of the string stack is false, we will skip the rest and go straight to the end. We return to the main macro where we find an add drop. And another one. We're done now. That was a conditional branch. Can we do loops? Let's see. This is part of the Ford Object Orientation System or 4TH. It's a macro that allows you to declare the private properties and methods of a class definition. We got our string stack and our output file. Now let's see how it handles this expression. We'll run it a bit quicker though. We start by calling the underscore private definition straight away. We parse the next token and put it on the string stack. Then we duplicate the top of the string stack. Subsequently, we push the closing curly brace token on the string stack. Add until compares the top two strings on the stack, and if they match, that means a zero flag. We skip the rest of the macro and go straight to the end. In this case, they don't match, and we continue by dropping the flag. Height is simply a token, and hence must be printed as is. We print the top of the string stack, which is the token clone. And then, surprise surprise, we call the same macro again. So we parse a token and put it on the stack. We duplicate the top of the stack. Then we push the closing curly brace token. But this time the tokens do match, so we quit the macro. Once returned, we find ourselves an add drop. And another one. And we're done. And this, ladies and gentlemen, is how you do a loop. I know what you're thinking. That's all very nice, but all my life I worked with CPP and I never felt like I missed out on anything. So what's the point? Let me show you. Yeah, that's cute. You can evaluate a factorial at compile time. I see. You're not impressed. Okay, you got it. It can even compute signs. Nice, but no cigar? I see what you're thinking. Haven't you seen this before? No, you haven't. It generates a text file with a sine wave. And to take this one to the limit, it can even generate a Mandelbrot in ASCII. Et maintenant, la pièce de résistance. Yes, it's object-oriented. Yes, it's 4TH. This is what our preprocessor can do. It can take object-oriented code and turn it into something that can be compiled by an unmodified 4TH compiler. It's got abstraction, classes, methods, encapsulation, virtual methods, constructors, destructors, inheritance, polymorphism, the whole enchilada. And yes, it works as well. So, is that all? No, it can do even more. But I'll cover all that in the last episode. I'm Hans Bezemer and this was yet another episode of Back and Forth. Don't forget to subscribe, I don't make a penny by making these vids. And all the work is done in my free time, so if you appreciate the effort, let me know. Toodledokie and bye bye.